Hello students, welcome to the next class. In this particular session, we are going to look on user-defined function, something known as recursive function. So we have already discussed recursive function in our lectures. So in this hands-on session, we are basically looking on how to make the program to implement a recursive function in C programming. So what is a recursive function? Recursive function basically a function calling itself from the definition of the same particular function is known as recursive function. Till now we have seen the functions. There is a called function, there is a calling function. So suppose a function is calling another function, then that function is known as the calling function, and the function that is called, that function is known as the called function. So basically, to implement recursive function, the best example is to implement it on a problem, that is the factorial problem. So starting from hash include stdio.h, that is a standard input output library. Second is hash include stdlib.h, that is a standard library. Next is inside the main function, suppose we are taking two functions, that is a main function and as a fact function. So inside the main function, what we have to do is we have to declare a variable, a num variable. For example, I want to calculate the factorial of a number, that is number is given by the user. So we are taking that number as a variable, so int num, and second is r. Suppose the result we are interested in taking from that particular function. So next is we are printing a statement, printf, enter the number for which you want to calculate the factorial. Alright, so enter a number for which you want to calculate the factorial. Simply using \n, that is next line statement, and that number we are storing in the variable %d and address of num. So %d is a format specifier for integer, and we are storing that number into num variable. So after this next line will be the function calling. Suppose our function name is fact is the function name in which we are calculating factorial, and factorial we are calculating for the number, that is some single number, and that is a type of integer. So we are passing int, and it is returning a integer also. So int fact int, and after this a semicolon. So this is the function declaration. So after this, what we have to do is we have to call that function. So function calling, simply write the function name inside the parenthesis. If there are arguments, pass those arguments. So yes, there is an argument, that is number, so we have to pass that argument. So we are passing num inside that particular function. So we'll come back to it later. So this function is giving us a return integer, so we need to collect that also, but we will come to that topic later on. So the next thing is, after this, the control will be inside the fact function. So the fact function is int fact, and it is collecting num into same variable, or you can take another variable, it is up to your choice. So I'm taking the same variable, int num. So inside function definition, what we have to do is we have declared num here, so no need to declare it again. So inside this, what we have to do is we have to declare a variable of integer type, int result, let's say int result. And as we all know that the factorial of 0 is equal to 1. So if num equals to 0, that is if number equals to 0, that means result equal to 1. If number is 0, that means result will become 1, Otherwise, in the else part, what will happen is, inside the else part, function will call itself. Function will call itself. That means result equal to num into fact of num minus 1. And after this, we are return result. And we have seen this very clearly in our classroom, that how this iterate using the arrows, certain arrows. So this function, suppose first time it is called from the main function. Here we have called this, the fact is called from the main function, and when control came here, the fact function, inside the fact function, what is happening? The function again calling itself from the definition of the same function. That means it is calling it again and again till the point where number will become 0. It is calling it again and again, and after this we are returning the result. That is it. Now it is returning a result. There is an integer. That means the returned value where the function we need to collect in the main function, the calling function. So it is returning something equal to, and we are collecting this value inside the variable r. Inside the variable r. After this, using the printf statement, we will write the factorial of %d is %d. The factorial of %d is %d. So factorial of num equals to r. That's it. And after this, our code is over. Now what we have to do is save it, and let's run it from going to the files, open it in terminal. Another number for which you want to calculate the factorial. Suppose I want to calculate the factorial for number 5. So let's press it. The factorial of 5 is 120. So the factorial of 5 is 120. So now to make it more understandable how things are going on over here, we will add certain statements. For example, I want to know at which point of time the program control left the main function. So before calling this function, the program control left the main function. So I should write printf. This is just for the understanding. The program is over. This part is just for the understanding more clearly how things are going on over here. Printf, the program control, or let's say the control, left the main function. The program control left the main function. Clear? But it is not actually leaving at this line. It is leaving after function calling. So we have wrote this line one line before, but it is actually leaving the program control leaving the main function after the execution of this part, the fact function calling part. After this, we'll write another line, that another statement for that. Let's say printf, because inside this what will happen is printf running the recursive function, running the recursive function, and \n for the next line. Now we should also take a count variable to know how many times the function called itself. So from the global declaration, we are declaring an integer type variable int count equals to 0. Now after this, we are increasing count ++, and what happens is, now again we want to know at which point of time the program control get back to the main function. So after this part, after the execution of this part, program control got back to the main function. So we'll write printf, the control is again inside the main function. control is again inside the main function. So the next line statement over here. Now close it, and we should also write a statement that the factorial of percentage d is percentage d, and we'll write, to make it more understandable, and the number of line or number of times, and the number of times the recursive function run is percentage d, and again what we are using is the variable count. So let's save it and run it. What happens? Go back to the files where your file is saved, open it in terminal, write the command gcc file name is fnr.c-o and fn for the executable file name, hit enter, /fn, enter the number for which you want to calculate the factorial, enter number 5. So when I pressed 5, the control left the main function and running the recursive function again and again, running the recursive function, and the control is again inside the main function. The factorial of 5 is 120, and the number of times the recursive function ran is 6. Clear? So now again, for example, I want to calculate the recursive function. I want to calculate the factorial using recursive function of number, let's say a bigger number, 23 for example. So I'm pressing 23, hit enter. So you can see it is running again and again. The size has increased because the factor of 23 is this, and the number of times the recursive function ran is 24. That is it. So the second part that we have added, we added this statement is just for understanding. Without this, the code will work again. So it is just for making it more easier to understand at which part the main function left, at which part the control left the main function, and at which part the control left the recursive function, for this. So as of now, for this session, it is enough. From the next and subsequent sessions, we'll look on storage classes. So thank you very much.